My name's Fernando, and I'm a technical marketing manager here at GitLab. And today we're going to go over how GitLab helps you solve a SQL injection.
Now let's go over how GitLab can assist us in resolving a vulnerability. GitLab provides many different resources to help us resolve a vulnerability, which includes the line of code where it was detected, security education from various different vendors, solutions to the vulnerability, links to the CVE, and much more. These resources can be seen within the GitLab Vulnerability Report as well as within a merge request, providing a single source of truth for both developers and the security team. GitLab now newly provides AI-assisted vulnerability recommendations. These recommendations use large language models which are powered by Google AI. These models are used alongside your code to provide you insights on the vulnerability, details on how it can be exploited, and how it can be resolved. We'll go over all of these features within this video and show how GitLab solutions are a whole-in-one. Now let's take a look at the vulnerability report. We can access it by going to the Secure tab and clicking on Vulnerability Report. Here, we can sort all the vulnerabilities within the default branch by status, severity, what scanner we're using, as well as if there has been any activity on the vulnerability. I'm going to go ahead and sort by SAST, or Static Application Security Scanner, which scans my static source code for vulnerable patterns. This is where I'll find my SQL injection under improper neutralization of special elements used in a SQL command, SQL injection. Clicking on it takes us to the vulnerability page view that provides details on the vulnerability that has been detected. It also allows the security team to triage and change the state of the vulnerability. Now let's go over the resources we have at hand in order to assist us in resolving the vulnerability. We can see here that we are provided with the line of code that is suspected to contain a SQL injection vulnerability. This shows us exactly where we need to edit the code in order to resolve this. Next, we can see a couple of identifiers which provide us an insight as to what is causing the vulnerability. Note that the resources and links may vary depending on the scanner used. The first link we see is bandit.b608. This provides us with the rule which was applied to detect the vulnerability. This educates us on the possible patterns which cause a SQL injection. These rules can also be customized or more can be added. The next link we'll look at is CWE89. A CWE is a common weakness enumeration. The CWE is a community-developed list of software and hardware weakness types. It serves as a common language, a measuring stick for security tools, and a baseline for weakness identification, mitigation, and prevention efforts. It not only educates you on how the vulnerability can affect your system, but also provides detailed examples on how to exploit it. GitLab also provides security training for vulnerabilities. This further educates developers to become more security aware and learn how to resolve vulnerabilities themselves. Developers can view security training from selected educational providers relevant to the detected vulnerability. These tools not only provide examples, but also contain exercises to make learning fun. Now let's show GitLab's cool new feature, Explain This Vulnerability. This feature leverages the power of AI not only to explain this vulnerability, but also to provide additional insights on how to exploit it as well as how to resolve it. You can see when I clicked Try It Out, a side tab opened up. It explains how this vulnerability occurs and provides a code snippet such as this right here, showing how an attacker can bypass the where clause and select all the data from the users table. It shows details that it can be exploited by sending malicious user input into our application. We also have a how to fix the vulnerability section that shows us the possible solutions we can take to resolve this. All this is provided along with useful references, such as the SQL injection prevention cheat sheet and the OWASP SQL injection page. Now that we've seen the resources we can leverage, let's go ahead and exploit the SQL injection. Note, there's a full tutorial on this demo environment which anyone can use in order to get familiar with GitLab DevSecOps. Please see the links in the description for more information. First thing I'm going to do is access my production level application, which was deployed using the default branch. Here is my simple notes application where I can go ahead and add new notes as well as delete notes and log in as an administrator. I'm going to go ahead and populate the notes database with a couple of notes. Then I'll log in as an administrator and I'll add secret notes. Now, user notes can be seen by anyone, but administrator notes should only be seen by an administrator. Let me add a couple more notes, and then I'll go back to the regular view, and we can see that the administrator notes are not there. Now let's open up our terminal and try to obtain the notes via the API. This can happen by performing a curl on the endpoint where the application was deployed and its ingress route / API. You can see once I curl the standard API, I get the basic notes, not including the secret notes. I can even scope down to note 1, which shows us cat. Now I'll try to perform a curl on note 5, which should only be an administrator note, and we can see that there's nothing detected, which is expected because we are unauthenticated. Now let's try to perform the same command, but on the admin API. And we can see unauthorized access because we did not provide our credentials. Now let's perform the same call, but with credentials. And we can see that note 5 exists and is meow as we specified. This is all as expected, but there are no known breaches. But we do know from the information provided by GitLab that it is possible for a SQL injection to expose our data. Now I'm going to run the exact same unauthenticated call, but I'm going to pass in the ID with a malicious query. And bam, all of our information has been exposed in unauthenticated mode, including our secret entries. This is an example of how a hacker can use a SQL injection in order to expose data from our system. The malicious query I used is just a URL encoded version similar to what was provided in Explain This Vulnerability. I used all the identifiers and relevant education, as well as the AI Explain This Vulnerability feature to help me learn how to exploit this vulnerability, as well as how it works. Now that we've seen the vulnerability and how it can be exploited within our system, let's go ahead and resolve it. I'm going to go back to the line of code where the vulnerability was detected. This was in db.py line 100. Using the data provided within the vulnerability report, I know that one of the possible solutions is to use parameterized queries instead of directly passing in the ID variable. This prevents the attacker from being able to inject their own SQL commands into the query. Now let's go ahead and edit our code. We can use the built-in GitLab IDE. Here we can make edits directly from the web. Let's scroll down to line 100, and we can parameterize our queries by removing the ID string and instead passing the ID to where the query is executed. Note that all this information is provided to you using the resources within the vulnerability report. You can also see that GitLab Code Suggestions is auto-populating some of the suggested code, making resolving this vulnerability and writing code easier than ever. Now let's go ahead and apply this code to a new branch. I'm going to go ahead and click on the little side tab and create a new branch to apply this change to. I don't want to apply it to main because I want to test it in staging first before I commit it to production. This assures that my change does not break the current application. Now let's go ahead and create a merge request for this branch. We can give it a title and description to make it easier to track. I'll say use parameterized queries to resolve SQL injection in select nodes by ID. And I'll assign this to myself. And then I'll create the merge request. And now let's go ahead and test the fix. We must wait for the pipeline to complete and deploy to our staging environment in order to be able to test if the SQL injection was resolved. When the pipeline is done running, we can see the View App button. If we click this button, it will take us to the application deployed from our feature branch, fix-sql-inj. We can see here that there are extra items which are included from the dast run. I'm going to go ahead and go to admin mode and reset the database table so we can start fresh. Then I'll go back to the regular view so we can try to exploit this vulnerability again. Now let's go ahead and add a couple of notes. And then let's go back to admin mode and add 2 more secret notes. Meow and woof will do just fine. And then let's go back to the standard view and we can see that the secret notes are not visible. Now let's go back to the terminal and try to perform the SQL injection. First, I'll just access the notes via the API. And all looks good here. We're not seeing any of the secret notes, just the notes created in unauthenticated mode. Now, let's take a look at the notes we created as an admin. I'll go ahead and pass my admin credentials, and we can see a mix of secret notes and regular notes, as expected. Now let's try to perform the SQL injection by passing in a malicious query. I'll go ahead and perform the same unauthenticated call with the URL encoded 1 or 1 equals 1. If there is still a SQL injection vulnerability, then this command should output all the notes, including secret notes. Now let's go ahead and perform the call. And we can see that only note 1 was actually displayed. If we try to manipulate it further and say 2 or 1 equals 1, we can see the second note. We'll try for the third note and see that nothing is displayed. This is because it is a secret note and we are in unauthenticated mode. Hence, we have solved the SQL injection. You can run through this example yourself, as well as learn more about DevSecOps with GitLab with the provided demo environments. They can all be accessed using the links in the description. Thanks for watching, and I hope you enjoyed. To learn more about how GitLab can help you resolve security vulnerabilities, check out the links in the description. For similar content, be sure to click on that subscribe button.